In this video, I'll talk about the reaction of organometallics with carbon dioxide. This is really one of the great ways of adding in a carbon and eventually getting in an acid at the end of the day. So here, the organometallics that we're going to be primarily talking about, or that kind of works really great with the CO2, is going to be your Grignards and the organolithium. So I can have an RLi or RMGBr. So those are the two main ones that works really well with the CO2. Now, suppose if I have a formaldehyde, so something like this, and I want to go ahead and add an organometallics to it, and let's say I'm going to go ahead and use a benzene with a negative charge there. And remember how you actually get that to begin with. I can have a bromobenzene or something like that, and I can use magnesium with ether, and that actually makes the Grignard here. And I could have used the lithium as well with the hexane, so it doesn't really matter which one you want to make, but it does have potential to make any one of those. So I get a negative charge on that carbon here, and eventually I can do this backside, I can do this nucleophilic attack on that carbonyl carbon, and as a result, this is going to break open, and what I get at the end of the day is I have this aromatic ring, makes a new bond, and then remember I got the carbon now with one oxygen there and two hydrogens there. And I don't necessarily need to draw the hydrogens, but I'll just draw those so that we can keep track of them. And then I can go ahead and protonate this in the second step with using acid water, and I'll end up making an alcohol. Now, if I want to go ahead and oxidize this alcohol, according to my wish, like I can literally do whatever I want at this point with this to make something else. Like this is a primary and a benzylic alcohol, so I can, if I use, let's say, PCC, I will end up making an aldehyde out of this. So I'll go ahead and get an aldehyde made. So I'm just going to erase some of these things to kind of draw this a little bit better. So I'm making an aldehyde. And using PCC or Swarton oxidation, remember, it will stop it at an aldehyde. But I can certainly go ahead and use KMNO4 as well. So I don't, not really limited to use that oxidizing agent. And if I go ahead and use that, I'll end up getting an acid. So I'll have a carboxylic acid here. And obviously, if I want to go make an aldehyde first, and from the aldehyde, you can use a stronger oxidizing agent, something like KMNO4, even like K2CR2O7, and that would eventually change it to an acid. Now, there's really nothing wrong with that process, and the only downside is kind of hard to deal with in a formaldehyde. It's not very stable as alone, and sometimes it may be mixed up with water. And if you have any protic solvents to begin with, it's not going to be we're not going to be able to get that reaction going, because that carbon with a negative charge would act as a base and run an acid-base reaction with a protic solvent. So a better way of doing it, and it's kind of also practical, like you use the organometallics here, so something like that. So that could be coming from Grignards or organolithium. And I literally go and throw some dry ice in there, so CO2 in there in the solution, and it works really well. So what I have, CO2 in there, it's gonna go ahead and attack this carbon, because remember, the bond is still polar. Even though the carbon dioxide overall is nonpolar, the bond between the carbon and oxygen is still polar. So I can go ahead and break one of those sides here, and what I really got here is a carbon-carbon bond. And then one of the carbonyls will still be there, and I have an O minus there. And then eventually I want to go ahead and use in a second step to protonate that. So I'll probably use an acid in this case, because that's an carboxylic acid we're trying to get here, not an alcohol. So that makes an carboxylic acid with one extra carbon in there. Um, So that's a really good way of extending the carbon chain, making the carboxylic acid as well from and then a Grignard reagents in the organo lithiums in that particular case.